The New Glenn rocket, notorious for its constant delays and persistent problems, has finally launched for the first time. Initially planned for January 8th, the launch faced delays due to a series of complications. During final preparations, engineers identified a technical anomaly related to the rocket's auxiliary power unit. Ice formation was detected in a purge line of the auxiliary power unit, which is essential for powering the rocket's hydraulic systems. This issue prompted a postponement as the team worked to address it. The launch was rescheduled for January 10th, but the same issue reoccurred during pre-launch checks, necessitating another delay. By January 12th, another attempt was planned. However, on that day, an additional complication arose when a boat entered the designated safety zone in the Atlantic Ocean, violating the range and causing a hold in the countdown. This, combined with ongoing technical concerns, led to yet another rescheduling. Finally, on January 16th, all technical issues were resolved, and range safety was confirmed. The launch countdown proceeded smoothly, and at 2 a.m., the New Glenn rocket successfully lifted off from Launch Complex 36 at Cape Canaveral Space Force Station. This marked the first orbital flight for the massive vehicle, standing at 320 feet tall and designed to carry heavy payloads into space. The New Glenn rocket features a two-stage design, with the first stage powered by 7 BE-4 engines that burn liquefied natural gas and liquid oxygen. These engines collectively generate approximately 3.85 million pounds of thrust at liftoff. Following stage separation, the second stage is powered by 2 BE-3U engines optimized for operation in a vacuum, burning liquid hydrogen and liquid oxygen. For this mission, the payload was the Blue Ring Pathfinder, a prototype spacecraft platform designed to test various flight systems and technologies. At liftoff, the BE-4 engines performed nominally, propelling the rocket through the dense lower atmosphere. The vehicle passed through max Q, the point of maximum aerodynamic pressure, without incident. Roughly 190 seconds into the flight, the first stage engines shut down, and stage separation was successfully executed. The second stage ignited its BE-3U engines to continue the journey to orbit. The first stage, named GS-1, was programmed to execute a controlled descent and land on Blue Origin's autonomous drone ship, stationed several hundred miles downrange in the Atlantic Ocean. During descent, telemetry indicated that the booster was traveling at approximately Mach 5.5 at an altitude of 84,226 feet before contact was lost. Analysis revealed that the booster failed to execute a successful landing burn, resulting in a high-velocity impact with the ocean surface. Despite this setback, the second stage continued its mission without anomalies. The BE-3U engines performed as expected, and the Blue Ring Pathfinder payload was successfully deployed into its designated medium Earth orbit. Communications with the payload confirmed nominal operation, marking a successful primary mission objective for the flight. While the New Glenn rocket reached orbit on its first attempt, the failure to recover the first stage booster remains a significant challenge for Blue Origin. The loss of the GS-1 booster was attributed to issues during the landing sequence. Telemetry data suggested that the booster did not perform the landing burn as intended, leading to its destruction upon impact. Blue Origin's engineering team has since launched a thorough investigation to identify the root cause of the failure. Blue Origin, despite its high-profile status and backing from Jeff Bezos, has struggled to make a significant impact in the commercial space industry. The company operates at a massive annual loss, with Bezos reportedly selling approximately $1 billion worth of Amazon stock every year to sustain it. This financial model underscores Blue Origin's lack of consistent revenue, a critical issue that plagues the company as it fails to secure frequent launches or lucrative contracts. In 2024, Blue Origin's launch cadence was strikingly low, with only a handful of launches from its suborbital New Shepard rocket. Compare this to SpaceX, which achieved 61 orbital launches in 2022 alone, representing almost half of the world's total orbital rocket launches for the year. This number increased to 96 launches in 2023 and further surged to 134 in 2024. SpaceX's remarkable frequency means that it launched more rockets than all other nations and private companies combined, a feat that Blue Origin cannot hope to replicate anytime soon. The reliability of SpaceX's rockets is another area where Blue Origin lags significantly. SpaceX has achieved over 230 consecutive successful launches with its Falcon 9 rocket as of early 2025, building an unmatched track record of dependability. Matching such a streak is incredibly challenging for any competitor, let alone Blue Origin, whose record is sporadic at best and limited to suborbital flights until the recent debut of the New Glenn rocket. The New Glenn launch in January 2025 attracted substantial attention within the space community, marking Blue Origin's first orbital flight. This milestone is undeniably significant for a company that has spent over 2 decades attempting to establish itself as a major player in the space industry. However, while this achievement is commendable, it raises the question of whether this single success can meaningfully change the company's trajectory. New Glenn has long been positioned by Blue Origin as a competitor to SpaceX's Starship, but the comparison reveals stark differences in capability, ambition, and achievements. New Glenn is a 2-stage, partially reusable rocket designed for heavy-lift missions, with its first stage intended for recovery and reuse. Standing at 320 feet, it is powered by 7 BE-4 engines that use liquefied natural gas and liquid oxygen as propellants, generating a combined thrust of approximately 3.85 million pounds. The rocket is designed to carry payloads of up to 45 metric tons to low Earth orbit in its reusable configuration, with a higher payload capacity in an expendable configuration. Starship, on the other hand, represents an entirely different class of rocket. It is a fully reusable 2-stage vehicle, with the first stage being the Super Heavy booster and the second stage the Starship spacecraft. Together, the system stands at an astonishing 394 feet, making it the largest rocket ever built. Super Heavy is powered by 33 Raptor engines, which also use methane and liquid oxygen, producing a combined thrust of 16.7 million pounds, more than 4 times that of New Glenn. The Starship spacecraft itself is designed to carry over 100 metric tons to low Earth orbit in a fully reusable configuration, a payload capacity that dwarfs New Glenn's capabilities. The differences in design and engineering translate directly into operational and strategic advantages for SpaceX. Starship's unprecedented payload capacity allows it to perform missions that are not feasible for New Glenn, such as launching massive cargo payloads, deploying multiple satellites in a single launch, and eventually supporting interplanetary missions. Starship is also designed for rapid reusability, with SpaceX aiming for turnaround times of hours or days between flights. This capability drastically reduces the cost per launch, enabling a launch frequency that New Glenn cannot match. In contrast, New Glenn's reusability is limited to its first stage, and its recovery and refurbishment processes remain unproven, especially after the failure of its first stage to land successfully during its maiden flight. In terms of testing and progress, SpaceX is years ahead of Blue Origin. Starship has already undergone several test flights, including orbital attempts. Although some of these flights ended in explosions, each provided valuable data that SpaceX has rapidly incorporated into design improvements. SpaceX's iterative approach to development has allowed it to achieve milestones at an extraordinary pace. By 2025, Starship has been integrated into NASA's Artemis program, with the spacecraft selected as the human landing system for the return to the Moon. This level of integration into government space initiatives underscores the trust and confidence that major organizations have in Starship's potential. Meanwhile, New Glenn's development has been slow and plagued by delays. Originally announced in 2016, its first flight was repeatedly postponed, with January 2025 marking its long-overdue debut. The BE-4 engines that power New Glenn were also delayed for years, affecting both Blue Origin and United Launch Alliance, which relies on the same engines for its Vulcan Centaur rocket. These delays have tarnished Blue Origin's reputation, raising doubts about its ability to deliver on its promises. That's all for today's video. Thanks for watching, and we'll see you in the next one.